Hello there, welcome to Chemipulse. This is Diana. I created this new channel about chemistry. So if you like it or if you want to learn something new, you are very welcome. Make sure to subscribe and also follow my Instagram account so you can be up to date with my new videos. This first video is about chemical kinetics. So let's start. Chemical kinetics is the branch of chemistry that deals with the study of the velocity in which a chemical reaction occurs. The word kinetics suggests change or movement. There are so many reasons to study the speed of a reaction. To begin with, there is curiosity about why reactions occurs at different times. The rates of chemical reactions vary greatly, and for example, the conversion of graphite to diamond takes in the crust earth take millions of years to complete. But explosive reactions like dynamite and TNT end up in a matter of seconds. Kinetics refers to speed of a reaction, which means the change in the concentration of a reactant or a product. And if we express that, it will be in the units moles per second. In this, we can see the reactants represented by the letter A and the products represented by the letter B. The velocity of a reaction is expressed in terms of change in the concentration in time. And for the reactants, which is represented by letter A, since the concentration decrease in time is a negative quantity and the velocity is a positive value, so it's necessary to put a negative sign in the formula. But in the case of the products, which is represented by letter B, that's a positive quantity because the concentration increase in time. The velocity of a reaction is directly proportional to the concentration of the reactants, elevated to their respective exponents. For a reaction like the ones we are seeing there, the first one, those are two reactants and we obtain two products. The law of velocity is represented in the second formula for that type of reaction. And there, the exponents x and y specify the relation between the concentration of the reactants A and B and the speed of reaction. And if we add them, we obtain the global order of the reaction. K is a constant. It's the coefficient of the reaction. It is the sum of all the exponents in which the concentrations of the reactants are elevated to, and that appears in the law of velocity. It is the group of phases that combine a reaction, and there are three types of mechanisms. It can be a combination, decomposition, or double scroll. So there are some factors that affect the velocity of a reaction. Those are temperature, catalysis, concentration, volume. It was proposed by Max Strauss and William Lewis, and it was in 1916. They said that the speed or velocity of a reaction is directly proportional to its number of collisions of molecules. So basically, what they try to say is that if we put a higher temperature, we have higher velocity. is the minimum energy required to start a chemical reaction. For example, a lighter. The equation of Arrhenius shows the dependency of the constant of velocity, represented by letter K, to temperature and the activation energy. So AE represents the collision frequency. EA is the activation energy. R, the letter R, is the universal constant for ideal gases. And letter T it represents the temperature. Here it says write down the expressions for velocity for the following reactions in functions of reactants and then products. The first reaction is we have two reactants. First one is iodine added with hypochlorite, and then we obtain chlorine and hypoiodine. We just need to substitute and use the formula that we saw in the law of velocity. We just need to we substitute, we use letter A for the reactant, so we use that in the first reaction, we have iodine. And for letter B, for the products, we use the chlorine, and we just need to keep substituting using the formula we saw before. So here it says, suppose that in a determined moment during a reaction of molecular oxygen, it's reacting with a velocity of 0.024 moles per second. So we see in the reaction we have 4 molecules of nitric oxide added with molecular oxygen. Then we obtain dinitrogen pentoxide. So the first question is with which velocity it is forming the dinitrogen pentoxide. And then it's asking what is the speed that is reacting the nitric oxide. So for the first question, we just need to substitute using the formula that we saw in law of velocity. So we have the reactants and the products. We already have the value of velocity for the molecular oxygen because the exercise already gave it to you. It says 0.024 moles per second. We just need to multiply that value by 2 because we have 2 molecules of dinitrogen pentoxide. So if we multiply it by 2, the result is 0.048 moles per second. And then for the second question, which is asking the speed that it's reacting the nitrogen dioxide, we just multiply it by 4 because in the reaction we have 4 molecules of nitrogen dioxide, so we just multiply it by 4 and we have the result with a negative sign, though it's 0.096 moles per second. So remember, you can send me your questions via email. All the information in this video, you can see it in the book of chemistry of Raymond Chang's. And yeah, our next topic will be chemical balance. So I hope I see you soon. Goodbye.